Hello scholars, welcome to Shalom. Today I'm going to give you secrets to get a job in IT companies in India easily. AWS is one of the fast growing cloud platform to shine in IT companies. Now, the AWS expert, Mr. Suresh Kumaresan, waiting to fire with his untold secrets. So, watch the video completely till the end.
Introduction to Cloud Technologies. Myself Suresh Kumaresan. I've been consulting and working in IT for the last 20 years. I'm also an Azure / AWS solution architect, cloud solution architect. So this video is for the new IT folks who's interested to get into the cloud technologies as their career path. So let's try to understand the traditional on-premises data center versus cloud. So the traditional data center is a physically located data center in the business building. Usually it would be in the same office location, or sometimes it's a managed or hosted data center somewhere close to the business location to run the business critical applications. And there would be an IT staffs, internal IT staffs of the company or partners who is responsible for maintaining and managing these systems, and also carrying out regular maintenance services like installing and upgrading software, security patches. So the traditional data centers usually is like we buy new hardwares, we have to do configuring and cabling, installing softwares. So it's more of the internal staffs kind of do all this, usually to build and bring up this hardware and applications. It used to take sometime few months. So that's our traditional infrastructure. And then we around in 2006, that's where Amazon published one of their services called EC2, which kind of popularized the cloud. So cloud is something that it's also a physical data centers, but hosted and managed by our vendors or providers like Microsoft Azure, Amazon. You have IBM, Alibaba, and a lot more in that space. So just a quick understanding here. If you see the slide in between both these images, so on the right side you see is the actual Amazon Azure cloud. You can see they have built the data centers across the globe, and it was also built with high availability zones. And on the left side you see a traditional data center, which mostly like hosted and managed by your company. And in between you can see what's the differentiation. In cloud usually have like three different models. One is infrastructure as a service, platform as a service, and software as a service. We'll more go deep into it later in the slide. But if you see on premises, you manage everything end to end, from hardware to servers, operating systems, runtime, middleware, data, and applications. So everything is you manage. In cloud, they have three models, three offerings. One is infrastructure as a service, where you manage anything above operating system layer to applications. In platform, you just manage the data and application. And in software, it's mostly like you get the access and everything is managed by mostly the providers. So that's the difference between the traditional versus the cloud infrastructure. So let's talk a little bit about the cloud computing. So this is according to our NIST standards. So as I say, the cloud computing is a model for enabling ubiquitous means like from everywhere. It's convenient, on demand, network access to a shared pool of configurable computing resources. So they kind of pool all these computing resources like network, servers, storage, databases, and on top of that you'll be able to provision rapidly your environment and then bring up the environment. So we do have like 4 deployment models. It's called the private cloud, community cloud, public cloud, and also it's all called hybrid or multi-cloud. So here you could see some of the advantages of the going to cloud. So one is cost savings, flexibility, reliability of the services, it's scalable, and you have unlimited storage, and it's easy to back up and restore, and you have quite a good performance in the cloud. It's actually also depends on how do you design in the cloud and which of the models you use. Based on that your performance is assessed. But usually the advantages of the public cloud is first is, let me try to explain you a little bit on the public cloud. So public cloud makes possible for anyone to access systems and services. Sometimes it's called less secure, but it's open to everyone, and so it's accessed through internet. Like general people can just go create an account and start spinning up the services that you need. Your services are measured based on the time frame that you run your service and kind of service you run. So you pay for what you use. So the advantage of the cloud is it's a minimal investment. You don't need to set up the data centers, procure hardwares, put together and build and all that. So it's a minimal investment, no substantial upfront fees, and it's excellent for enterprise that requires like an immediate access to the resources. So there is no setup cost. You can just go spin up on your own. And if you go for infrastructure as a service, you have to maintain only like on operating system and above, but there is no infrastructure management required, especially on the public cloud. So no maintenance, you have less maintenance activities, and it's dynamically scalable. So this is all the advantages that you have usually when you go for a public cloud. But there is also a disadvantage. One commonly they say is a little less secure compared to the other cloud models that we have, and it's low in customizations, so you can't customize for your requirements. So the other option that we have is the private cloud. So private cloud is more of an one-to-one environment for like a single customer. There is no need to share the hardware with anyone else. So that's the advantage of it, and you can handle all the hardware. So it is also called as an internal cloud. And usually the advantage of the private cloud is it's better control, and the key reason is you'll be the sole owner. It could be like you can host the private cloud, or also we have some providers now like HP data centers and others. They provide you a dedicated cloud environment for you on the private cloud. So usually they go for better control, administration, and data security and privacy reasons. And let's say if you have some legacy systems running, so that is all an advantage when you use a private cloud. So disadvantage usually is less scalable than the public cloud, but it is expensive to set up the whole data center and kind of build the private cloud. And you also have the other option or model, we call it as a community cloud. So usually the community cloud is it allows you to access all the systems and services, but for a group of organization. It's more designed for certain industry, like a distributed system for like a community or an industry or a business, for specific businesses like banking, insurance or government. So that's called community cloud. So the last one is the hybrid cloud. The hybrid cloud is also called as the multi-cloud. So here we are talking about like employees employing like a multi-cloud providers at the same time. Okay, it's similar to hybrid cloud, but it's a combination of both public and private cloud. So hybrid cloud usually is like you have a public cloud, but you extend the cloud into your on-premises. It gives you have both on-premises and the public cloud. So the multi-cloud is like you have a combination of both public and private cloud together. So that's the multi-cloud. So there's also like a high availability of services because you have a combination of both on-premises and cloud, public cloud services. So you have a combination of both. Only thing is the disadvantage is more complex. The complexity increases. So the cloud computing usually have, like as I told you, like deployment models, 4 deployment models, like we spoke, public, private, community, and hybrid. We also have 3 service model which we touch base, like infrastructure as a service, platform as a service, and software as a service. So usually infrastructure as a service is like you have an on-premises server like Windows or Linux. You bring that to the cloud and just run that. Only thing is you don't manage the hardware, but you manage everything above operating system. So you have to do your security updates, maintenance of the servers. You're responsible for the design. So platform as a service is you don't manage the server. You don't need to patch, maintain, or anything. This is just like database as a service. You just go, you can spin up a database and start consuming that. Software as a service, an example is just like create an Outlook account and start using it, or Dynamics is so you have some software as a service where you don't need to worry about anything, like it will be taken care by the provider. And with the cloud you usually have this 5 essential characteristics. One is the on-demand self-service. So a consumer can provision computing capabilities such as server or network or storage anytime without a human interaction with the service provider. So you'll get a portal, you'll log in, you can just go create the services. And it's a broad network access. So this means you can access your cloud with your laptops, workstations, mobile phones through the public internet. So it supports heterogeneous thin and thick clients. And you have a resource pooling. What that means is they pool all these different resources like network, compute all together, and so the provider computing resources are pooled, okay, to serve multiple customers. So that's how they build these data centers. So that's an advantage. So you have, like, you can scale your resource. Okay, that's also a rapid elasticity. So you can the capabilities that you can elastically provision and release the resources. So you can use the resources when needed and release them when not needed. And based on your company's business demand, you can scale up and down the resources. Okay, and the service is measured. So the cloud system usually is automatically controlled, and it to control and optimize resources uses by the leveraging metering capability. Okay, so there is some level of abstraction layer to the type of service. So you can split the cost for storage, processing, bandwidth, IOPS. For everything you have a separate billing, and you can measure that, and it's also every minute it monitors the billing every minute. So as soon as you stop the service, you stop the billing. So that's all like critical or important advantages of going to the cloud computing. So here are some of the major public cloud providers. If you see, this is the Gartner chart. So the leaders are Amazon Web Services, Microsoft, and Google. So Amazon is one of the very early cloud providers, so they're still on top in the market and as a leaders, and Microsoft is catching up, and Google is more of there as a visionaries. So how do I see as a cloud is, with my experience, Amazon is more flexible, and I think it's more like a DevOps platform. We'll touch base a little bit of DevOps, but it's more of a flexible cloud provider platforms, and Microsoft is more easy to use. It's whoever comes more from traditional infrastructure backgrounds, so usually the GUI and everything is more comfortable, like the easy icons to navigate around. So it's more of an infrastructure cloud. It's very easy for an infrastructure engineer to adopt Microsoft. And for Google is more of a developer cloud. Because it has a lot of analytics and other services, and you have a lot more clouds. You have Alibaba, Oracle, Rackspace, so the vast majority of cloud providers today. So let's talk a little bit about if you want to get into the cloud, where do you start? I'm going to cover more from an infrastructure background, because I'm kind of more comes from the infrastructure background, but I can give you an overview of other domains or other scope where you can also get into the cloud. So AWS offers these certifications, which is listed here. So one is foundational certificates, which usually validates your foundational level understanding of AWS services, and this costs about like $100 for the certification. So I would recommend, if you are very new to the cloud, this is the first certificate that which will give you a good understanding of foundational level. And then depending on where do you want to start, you can either go for a solution architect, which is more like an associate level. So that will help you in designing, building, like maintaining the AWS infrastructure. So usually all of the certification on the associate level cost around $150, and on the professional level it costs I think $300. And you also have a system ops, which is more like a DevOps engineer certification, where so this certification will help you kind of a little more into bringing your applications from on-premises, and you also like master the management console, implement, and you can also have more on operational controls, how to manage it. It talks more about that. And you have an AWS developer training builds. So this is more for the development team or the developers who are interested to get into the cloud. So it will help you to write code. You can design scalable applications, and you'll also learn more about components like S3, DynamoDBs, cloud formations, etc. And there you, on the professional level, it's more advanced. So to move to a professional level, you have to finish one of the associate level certificates, like a solution architect or system ops administrator, and then you can go on the professional level. And the other professional levels that you see here, or foundational, it is listed, it's actually more specialized certifications. So that talks about more advanced networking. If you come from networking background, I would recommend that. And for security, for the security team, the machine learning, which talks about more all the ML tools that AWS offers. Like you have so there's a lot of tools. I'll give you a glimpse of some. So you have like Elastic Map, reducer like EMR clusters. You have data analytics, data streams, Firehose, Glue. Something I could remember out of blue. So these are some of the services which will offer you more like a specialty trainings. So I would recommend you can sometimes, if you very well know the fundamentals, you can skip the cloud practitioners, but I would recommend doing one of the associate certificate to start in the AWS. So this is for Microsoft Azure. Azure offers much wider range of certificates to support. So usually here I would recommend to start with AZ900, which talks about more fundamentals of the Azure. Then you also, if you wanted to step in more like an Azure Cloud Engineer, I would recommend to go for AZ104, which is an Azure Administrators, which will help you to kind of manage the Azure identities, governance, implement and manage all the compute, storage and other resources. And then you have like AZ305, so that's more for designing an infrastructure, recommended for more solution architects. We have AZ400 for DevOps solutions, so that's for DevOps engineers. And we have AZ500 for security, who comes from security background, recommended to have some of these certificates, or even solution architects is recommended to have some of these certificates. And AZ700 talks about networking. And we have like a DB100, which this is all more like analytics and DB related services certificates. We do have like a DB100 for data science and DB300 for the database engineers. If you come from database, this is some, but you can take a look at it. There's a different kinds of certificates that you can go for it, but recommended to start with the fundamentals, AZ900, and then pick the right certifications that you want to go for. So Google is quite straightforward. You have three kinds of certification: foundation, architect and specialization. So foundation is usually the cloud engineer or G Suite, and you have a cloud architect. Then specialization depends on which background you're interested or you come from or you wanted to pursue. Many of the cloud engineers I've seen like who have done like certifications from all different clouds. So the underlying technology, if you understand the underlying technology, it's easy that you can, it's only the services that some differ and names differ and the way things are done, but at least you'll get the conceptually, you can understand the cloud easily. So I've just covered only 3 of these clouds because this is one of the major providers. So usually the cloud responsibility, let's say, is like they have different cloud teams. Okay. So some companies run like a plan team, build team and a run team. So usually the plan team works more on the strategy and governance, and then you have a build team which is more like an adoption team, okay, who adopts cloud, who also helps converting from on-premises to Azure or AWS. Adoption team. Then you have an operation team, and rest of the team depends. Sometimes they kind of consolidate security, automation and operations together. Sometimes it's split, depends on the organization size of the organizations, but this would be your basic responsibilities in the cloud. So this is something that I wanted any new joiners joining an organization or getting into cloud should have some of these basic knowledge. So one is IT framework and service management softwares. So you should be aware of these basic frameworks. About you join any IT service company, You should know like there's some tools that you have to use to kind of do your day-to-day work. So first you should understand IT framework. So this is some basic that you should know. You can also research some, look into the IT frameworks, and understand a little bit before you kind of get into any interviews or related to it. And there are different kinds of tools. Usually the very popular is one is ServiceNow, and the other one is the Remedy, which is the mostly used tool in the IT. So the next that you're supposed to know is the basics of networks. So getting into cloud or IT, this is something it's basic that you have to know. The basics of network is like you need to know the OSI model, the different layers, how the data or packet is passed across. Then you should know a little bit about the routing protocols which is in use and how it is used. I'm not going to go over every piece of the technology, just to give you an idea of what all you need to know before you get into cloud or even going for an interview. So, and you also need to know a little bit on all these network peripherals and devices, like what is a router or switch and how it works. A basic idea of all this about the networks. The first thing that you need to know is the ITSM framework and some of the tools, how to use that, manage it. And next is you should know what is computer networks. The other core important thing is you need to know about the operating systems. Okay, so there is like different flavors of operating systems. You have Unix, Linux, then you have Windows operating systems, you have Android, iOS, Mac OS, so Ubuntu and a lot more. But you should know at least a basic understanding of all this operating system, how it works. You should have an idea, good idea of all that. The next is you should know about what is IT storage and backup. So there's different kinds of storages today. In cloud, it's also a different kind of storage, where you have more like storage accounts that you create, but you don't necessarily manage the hardware. So you have like a DAS, called as like network attached storage, or storage a SAN. Sorry, I lost my brain a little. Okay, network attached storage or SAN. And you also need to know what are the different kinds of backup. So you have a full backup, you have incremental backup, differential backups. So all the different kinds of basics of backup. You should know all these types of backups and basics of all the storages. So SAN is more like storage attached network, which runs over the fibers, similar to NAS, and it has its own operating systems to manage. So you should have the basics of all the storage and backups. Next is you should know a little bit about the databases. What are the different kinds of databases exist today, and you should have a little bit idea about it. You have a SQL and non-SQL databases, as a relational and non-relational, and you have like OLAP, graph, document based databases. Here is some of the world's most popular databases I've listed here. So you not all the databases you should have a knowledge, but you should have a basic idea of what is databases, how it works, how they store the data, retrieve and all that. Next is, this is very critical, you should also understand and know about all the business applications which is used, because any company you go, there will be a set of applications they are going to use. One common application that you would see is called the Enterprise Resource Planning, ERP. So you have SAP, so Salesforce for CRM usually. So the ERP can have multiple modules, different modules where you can add human resource modules, marketing, sales. There could be one application which extends for all the organization, or they'll have multiple applications. But for every department there is different set of applications usually used, or some applications like integrates with all. So but you should understand the idea of different applications that different departments would use, and a little overview of what kind of enterprise softwares exist today. So you can see here, like they have like ERP, BI, business intelligence applications, supply chain applications, usually like Dynamics or Salesforce they use. So there are different kinds of, for project management, knowledge management, they use usually ServiceNow, or depends on the company, but this is little bit of idea of different kinds of application in use. So next critical piece is the data security. So there are 7 layers to security. So you could see here all the different layers of data security, and you also need to know like what are the different components or tools used in each of these layers, where antivirus is used versus vulnerability tools are used, or endpoint security used. So you should have an idea of the security, so that's very important. The next critical, or I would say the last piece that you should essentially know today to get into any of the cloud or IT related is the DevOps. DevOps is a combination of development and operations. You can see this DevOps cycle. So this is how most of the software development life cycle goes over, and you can see all different kinds of tools used in different phases. So you have a build, which is usually like a plan, build, then you have a continuous integration, then you deploy, operate, then continuous feedback, then it pipes into plan, and you have all hundreds of tools used to support this DevOps. But as a cloud engineer, the one core thing that you need to know is there is the whole cloud deployments, like you deploy a service or infrastructure, it is all through the code, which is today they use like an infrastructure as a code. It's a piece of code that you write and push, and you can get the services built in the cloud. So you don't there's also options that you can manually go to the portal, right click, build the services, but an enterprise level or the right approach to kind of deploy services is through some of these infrastructure as code. So where Terraform is an open source, and usually for Azure they use like Azure ARM templates. For AWS they use like CloudFormation. For Google they have this deployment managers. There's a lot of tools that you can use for infrastructure as a code. You can also just do it with PowerShell, CLI commands, but that's the preferred way. So you should know what is an infra as a code, and you should also know some of these configuration management as a code. So this is some of the DevOps tool sets, and then the processes that you can see here. So you should have a basic knowledge of all these, along with the cloud, 1 or 2 certifications in AWS or Azure to start with the cloud. I hope this video helps. Thank you so much. I would wish you a good luck on your IT cloud journey. Thank you.
I believe this video is so useful to all of you. If you like this video, like, share. To get more update, don't forget to subscribe and put your valuable comments. Thanks for watching the video. Have a good day. This is Samuel Chinnathambi. I'll catch up in the next video. Thank you.